So, how do you simplify an irrational number, you may ask? Look for factor pairs. And make sure when you look for factor pairs, try to find a number that contains a perfect square. So for instance, 80. Pretty big number, but I know 1 times 80 is 80. 2 times 40 is 80. Ooh, 4 times 20 is 80. 5 times 16 is 80. Now notice there's no 6, because 6 times a decimal will give you 80, so no 6 in our list, as well as 7, no 7s in our list. 8 times 10 is 80. So basically what I'm doing, I'm keeping in mind my divisibility rules. I'm trying to remember, how do I find factors of 80? Kind of comes in handy when we are factoring, if you might recall. Now once I make my list, I pick the biggest perfect square. And in this list, I know 1's a perfect square, I know 4's a perfect square, but 16's my biggest. So what I do is almost like a factor tree. I branch it down and I write the perfect square out in front. The square is 16. Technically speaking, there's times. You don't have to put the times symbol there, but if it helps you, square root of 5. The square root of 16 on a calculator is 4, all by itself. The square root of 5, if you type that in the calculator, get this big long decimal. That's why it makes this whole problem irrational. But this is the simplified answer for square root of 80. Same thing for 75. 3/4 makes 75 cents. So list the factor pairs. Ironically, there's only 3 factor pairs for 75. And the one we want is 3 times 25. So we put the 25 in front because it's the perfect square. Square root of 25 is 5, and we write the final answer 5 square roots of 3. By the way, this is the same if you want to write 5 times the square root of 3. But on a standardized test, when you write 5 times square root of 3, they just merge it together. Hence, the final answer, 5 radical 3, or 5 square roots of 3 is fine. Example number 3, same idea, square root of 40. List the factor pairs. Think of all the combinations of pairs and numbers you multiply together give you 40. Obviously 1 times 40. 2 times 20. No 3's here, right? 4 times 10, 5 times 8. Now the biggest perfect square circle is 4. So I write this down as 4 times the square root of 10. The square root of 4 is 2. Leave the square root of 10 alone. Example number 4, the number 27 doesn't have too many factor pairs. But it turns out the one we want is the 3 times 9. 9's the perfect square. So we put the 9 in front, take the square root of 9, which is 3, leave the square root of 3 behind. Example number 5, square root of 50. Now after a while, notice here, after a while, I don't have to show my work, I can remember. In fact, another trick, some of you might say, do I have to list all these factor pairs out? No. That's why, if you remember, those of us who we were together that short week before we had no more school, if we listed our perfect squares out first. So, back to my perfect square page. If I list my perfect squares, I could start with 49. Is 49 a factor of 50? No. Move to 36. Is 36. Can I divide 36 into 50? Nope. Bam, 25. So that's a second strategy some of you might remember from last year's algebra class. So if you don't want to list all your factor pairs, use your perfect square list and bam, you get your answer right away. Square root of 25 is 5. Same thing for 18. Maybe you don't want to list all the factors of 18. 1 times 18, 2 times 9, 3 times 6. If you look at your list of perfect squares, you'll see 9 right off the bat. Last example, the square root of 24. Now remember, you want the biggest perfect square. 4 is it. I know a lot of times people want to use 3 and 8, but neither 3 nor 8 is perfect. So you want to break down the square root of 4 as 2 square roots of 6.